Okay, so unit vectors. Unit vectors are pretty simple. It's just a vector in a certain direction with the magnitude of 1. So, like, let's say we had a vector, and this is just a normal vector, not a unit vector, and this is the vector in component form. So the unit vector would be the vector going in the same direction, but with a magnitude of 1, hence the term unit in the name. So the way we do this is the unit vector, which usually is represented with a little hat, that's equal to the vector over the magnitude of the vector, right? Because if we scale this entire thing down by the magnitude, well, then the entire magnitude is just going to be 1. So that's what we're doing here. Okay, so to do this, first we have to find the magnitude of the vector. So we've looked at two-dimensional vectors before, and that's kind of easy to solve the magnitude given its components. Like, let's say we just had the vector 2, 3. Then the magnitude of that vector, it would just be 2 here, 3. It would be the square root of 2 squared plus 3 squared, right? Because it's just the hypotenuse of the triangle that creates. Well, with a three-dimensional vector, or any dimensional vector, the magnitude is calculated the same exact way, except we just now have a third term to square. So the magnitude of this is going to be 1 square, the magnitude of v is going to be the square root of 1 squared plus negative 7 squared plus 4 squared, which is the square root of 1 plus 49 plus 16. So that is the square root of 66. And I don't know if this can be simplified because I honestly just picked random numbers. So this is 33 times 2, which is 11 times 3 times 2. So nope, it can't be simplified. So the magnitude is just 66. A square root of 66. And so now to find the actual unit vector, because remember this is just the magnitude, we have to do the vector, which is 1, negative 7, 4 over the square root of 66. Now you might be thinking like, what? This looks a little weird. It's a lot simpler than it looks. You just have to remember that you can also write this like 1, remember we said 1i minus 7j plus 4k, and this is a lot simpler to divide by square root 66. You could either leave it like this, or you could say 1 over square root 66 I minus 7 over square root 66 j plus 4 over square root 66 k, but we always like to rationalize our numbers, and I just picked random numbers, and that's why maybe I should have picked a nicer looking square root, but you're going to see a lot of ugly square roots, so I don't really think it matters. So we would get this, once we rationalized it, we're just multiplying the top and the bottom both by square root 66 just to rationalize the denominator. And so we get 7 square root 66 over 66j plus 4 square root 66 over 66, which is just 2 square root 66 over 33k, which I'm sure you know how to do. We're just getting rid of the radical in the denominator, and that looks a lot nicer. So yeah, that's all the unit vectors. This would be the unit vector for v, and if you wanted to square all of these magnitudes and add them up, you'd find that it did equal 1.